Before we proceed to drafting part or the drawing of the design frame, we need to add load combinations or add basic load cases. In this case, we are adding 10 load cases, which are the following. To add an additional load cases, delete unused load case like service and automate load, as they are default to the program. These are the following default load cases in the program. After that, then add additional load like proceeding to step 2, edit load combinations by putting the load factors. These are the load factors to be applied in the design load combinations. They are taken in NACP. But before obtaining these standards, we need to consider first our seismic response coefficient. This is the calculation for earthquake load, and after we can obtain our seismic coefficient, we can now input our earthquake load. The following standards for SRC or the seismic response coefficient are taken from the table 208-7 NACP 2015 edition. Remember that you must include the height of your design footing to the overall height you input to the lower column. Those are the members 28, 29, 30, 31, 32, and 33. What we are doing here is that we sequentially draft every members. Don't forget the nodal restraints to apply in the footing to make it more realistic. Nodal restraint is the kind of support to apply in footing. We are using fixed support with X and Y displacement, and Z rotation are fixed. Step 4. We have now the complete members of our frames that are arranged in sequence. Vertical members are the columns and horizontal for beams. To set dimensions for columns and beams, go to Change Member Properties, then input designated dimensions. For a wiser reminder, always save your data or file and make a raw copy of it for the other frames. Make it use as your default template for corresponding projects or future plans. After saving, let us proceed to applying the loads. Don't forget to change the load case every applying the calculated load in every member. Since we are done with applying the calculated loads, we are now proceeding to step 5. We are going to perform an analysis. This way, we can identify the forces that act on both horizontal and vertical members or the beams and columns. These are the forces that act on the following members. On beams, we have bending moment and shear force, while on columns, we have bending moment and axial force. Always remember to generate self-weight first before performing an analysis. If you have performed analysis and if an error appears, try to check if you have already generated the self-weight. To view forces, proceed to design envelope, then right-click. View the sequence of the member first. Click horizontal for beams. Remember that forces that act on the beam are design or the bending moment and the shear forces only. Next is that you need to click shear force to view shear forces that acts on the beam. The forces that acts on the column are the bending moment and the axial forces. If we are done with displaying the forces reactions, we can repeat the forces in the corresponding frames. After analyzing all frames, proceed to identifying the maximum values. We can display the maximum values in any process we know. We can use different softwares like CAD, Paint, and etc. But in this process, I use CAD to import from GRASP. So these are the following maximum values that we are going to input in our details to design. In designing or calculating, we are using Microsoft Excel. And we are done.
So now we will be using PlanSwift for now. And let's have a tutorial for this software. For this, click New, add job, for example 1, and add description, sample estimates. Then click Next. Then select a file. This software is used when the file you wanted to measure is in a PDF file. So there, we will export now the PDF file. So we have now the key plans in each floor of the building. So here at the ground floor, we need to use the functions we need to scale first. Since the dimensions are in meters, so we use meters. So 8 meters, we plot it here. And on the other side, we can also use 2 meters and 8 meters as long as the dimensions are present in the key plan. So there, the drawing has been scaled, so we can now use the area. So in this floor plan, we need to get the area of the cafe or restaurant. So just plot the points. So the area for this will be seen if you right click your mouse and show legend. So the cafe's area is 40.8 square meters. So if you want to try it with another location, let's do it in the toilet area in the pharmacy. So toilet, pharmacy toilet. So just plot the key points. And then there. You can also see the area of pharmacy toilet is 2.6 square meters. So let's do it with different locations, like the toilets here. Different locations, but we obtain a total area of the 3 locations. So this is the first area, second one, and the third one. Just click the new sections if you want to add any other new area. So here the area of the 3 toilets is 8.5 square meters. So for the next function is for the linear meter, in which this will provide you a linear meter for any location. So for example, you want to get the linear meter of CHB with 6 inches thickness. So here at the ramp, the linear meter of the ramp is equal to 40.5 meters. So that is the linear meter of concrete hollow blocks with 6 inches thickness. So for another example, concrete hollow blocks with 4 inches thickness. So just plot the points of your location. New section, then here. So there, the linear meter of CHB4 is 23.5 meters. So for another function is the segment. Linear meter and segment is a bit similar, but then here's the difference between the two. So ultrasound department. So in the segment function, you don't need to click new section because the segment can automatically provide a new line in which you will not click anymore the new section. So here is the 34 meters of ultrasound department. So for the next is count. The count function counts the specific windows or doors you want to count. So if you want to count the W7, you just click the windows with W7 there. So there are 7 W7 on our count, but if you wish to add W7, just click the old one, then new section, then click the new one. So we have a total of 8 W7. So if you want to add a note, just click note, then add some can also change the color of the note, the text color, the border color, and you can also adjust the transparency and the text height. So these are the basics of PlanSwift. So if you wish to learn more about PlanSwift, you can search now a lot in YouTube. So if you wish to print this file, just click print, then set up printer. You can choose your printer or Microsoft PDF or anything you want. Then set the size and the orientation, then OK. Then click print. So now for this example, we will name it ground floor. Then save. Then close. Then open the file. PDF ground floor. There, we have our PDF file of the one that we measured in PlanSwift. So that's for PlanSwift. Thank you guys.